Question 2. A geometric series has first term A and common ratio R. Given that the third term in the series is 64, the rule of nth term for a geometric series is A R power n minus 1. If the third term in the series is 64, this means that A R power 3 minus 1, which is 2, is equal to 64. This is the first equation. Second equation, also A R power 6 minus 1, because this is the sixth term. 6 minus 1 is 5, equal to negative 8, and solve simultaneous. I can divide both equations. I can make A subject from the first equation. So A will be equal 64 over R squared, and substitute in the second one 64 over R squared times R power 5 equal to negative 8. Negative 8. 64 R power 5 over R power 2 is R power 3. 64 R power 3 equal to negative 8. Move the 64 by division. It will be and cubic root, so R will be equal cubic root 8 over 64 at once, which will be equal cubic root 8 is equal to 2, and cubic root 64 is equal to 4, I guess. Is equal to 4. And this is negative, so negative 2 over 4, which is negative half. No need for calculator. Of course, you can write it in the calculator. Cubic root shift root negative 8 over 64, negative half. Okay, this is part A. Someone else might have thought different, and he will assume that 64 is the first term. A is equal to 64, and negative 8 now will be the fourth term. If first term, second term, third term, fourth, fifth, sixth. The third term is 64. Okay, the third term is 64. I will assume that this is 1. Now this will be 2, and this will be 3, and this will be 4. And he will write 64, which is A, times R, power 4 minus 1, which is power 3, equal to how much? Negative 8. Okay, move the 64 by division, you will get the same R. But don't forget to go back and find the A for part B of the question. Find the sum to infinity. I have to use the original A, the first term. Okay, because if someone substituted A by 64, it will give a wrong answer. So this is a common mistake for those who will assume that the third term is now the first term, will assume that the third term is A, and will assume that the sixth term is the fourth now, and find R. When he moves to part B, he forgets to find the original A, which is the first term actually for this series. Got it? Anyways, he wants the sum to infinity of the series. I can find the sum of infinity because the R is between 1 and negative 1. That's why sum of infinity is valid in this case. Sum of infinity, the rule is in the formula sheet, and it is so simple. Sum of infinity is equal to A over 1 minus R. R is equal to negative half, so A will be equal 64 over negative half squared. 64 over negative half squared, bracket negative half squared, 256. A is equal to 256. So the sum of infinity is 256 over 1 minus r, which is negative half, 256 over 1.5, 512 over 3. 12 over 3. The 1.5 comes from the denominator. 1 minus half, which is 1 plus half, which is 1.5. Fine, everyone. Let's move to the next one.